Yeah, we're gonna screencast today. Natalie.
And Shelly.
Okay, so let me just go back, review, because I think right at the beginning of homework, they had things in terms of why, right? And I said that it was basically the same idea, but we'll get through some actual examples today. So when we're doing the area between two curves, what do we need to do?
Top minus.
Okay, top minus bottom, and what about the bounds? Or the limits of
From
integration?
the end one.
The endpoints. And sometimes they're actually intersecting, so we have to figure out, like this last problem that we did, we had to, you could just look at the graph if we graphed it properly, but if we didn't sketch our graph so well, then we would have to solve algebraically to figure out the x-coordinates where they intersect. Okay, so today, we will continue, and let's look at this example. So this is a calculator problem. Find the area of the region enclosed by the graphs of y equals 2 cosine x and y equals x squared minus 1 using a graphing calculator. So let's not, I'm not going to get into the program just yet. Let's just figure out where these two intersect. So that you do have to figure out on your calculator. So in your y1, go ahead and put 2 cosine x and then y2 put x squared minus 1. And make sure that you are in radians, not degrees. Oh, you don't. Oh, okay. It's not actually good. It's mine. What's wrong?
I open the program first, but then I play it, and then when I like my graph, came out like this.
Oh, okay.
You have to restate the window.
Oh, so your graph got messed up. So 2 cosine x and x squared minus 1. No, we're not going to use the program just yet. Now, in terms of the viewing window, I would probably just use the window that they have there from -3 to 3 and -2 to 3. What happened?
I have the two things in my y equals and then it's on the back.
The axes are probably so small that you just don't.
No, it's on the
So you didn't put the program properly.
I did put the program properly. Thanks for looking at my calculator while I did that.
All right, so how do we figure out the intersections? Right, just second, Calc. Or second trace. And we want to find the intersection. Does it really matter which one we find first? No, and what else? Since these are symmetric. Wait, we do second Calc 0? Not 0, intersection. What is it? Number 5. Oh.
So where do you put the...
So what is the point that we really need? We don't really care about the y coordinate, we just care about the x coordinate. You could write down both points. So let's make sure we go to 3 decimal places, because that's what they're always going to look for in the AP. So what is that? Okay, so you only have 2 graphs in your y1 and y2, right? So it's just going to automatically pick the first curve. Will probably jump to y1, and then press enter, and it's going to jump to y2. And then when it says guess, so the reason for the guess is that you can zoom, like you can trace. If you move when it says guess, if you move the cursor closer to the right, it's going to go to this intersection point. Whereas if when it says, you know how it prompts you and it says guess, you could actually put in a number, or you could just move using your arrows to get closer to the point that you're trying to locate. That makes sense. Okay. Not really? Let me explain. Again, let me just show you. So when I go to second trace, and I want to find the intersection, so that's number 5. So right away, it's going to say first curve, and it's going to have a question mark. So our first curve is 2 cosine x. That's fine. I'll just press enter. Second curve. The reason this does this is sometimes that we have more than 2 graphs that maybe we've had 3 graphs that we plugged in. And if you're looking for an intersection, you can only choose 2 at a time. So our second curve, yes. So it's kind of like when we press enter, it's like yes, confirming that's our curve. Now it's going to ask you to say guess. Because my cursor is over here, it's going to find the intersection over here. But what if I don't want to know that intersection? I want to get the one over on the left side. So just use your arrows. As long as I'm closer to that one than the other one, it's going to give me this intersection on the left. So that's what the guess is for. Because sometimes graphs only have one point where they intersect, and sometimes they have multiple places. That too. And notice this is symmetric, so this is just negative 1.265. So this is negative 1.265, and this is going to be positive 1.265. Again, the y coordinates are irrelevant when we're finding the area with regards to x. Okay, so how do we set up our integral? And which one do we want? Be careful here. Which one is the upper curve and which one? 2 cosine x is the top one. Minus x squared minus 1, so it'll become plus 1 dx. So I would just do math 9, negative.
You can do it on the homework, right? Because whenever I do that,
Right.
it never comes out. But my calculator magically does.
It magically does. So in this chapter, this last chapter, I'm mainly testing you on can you set up the integral properly, because that's actually what you're going to be testing more on the AP. Can you set it up properly? You should be able to plug it into your calculator just fine, but can you do the setup? So you'll notice, like, on the test that I'm going to give, I'll say, set up but do not evaluate, the volume between these 2 curves.
Or is the whole test going to be probably okay or no?
Yeah. Okay, so what do we get? 4.995?
What was the
So it's units squared. I'm not so concerned about including units on these since they're not application problems. If you put units squared, that would be fine. Any questions so far? Okay, so sometimes it's not so clear what is your upper curve and which one's your lower curve. And sometimes things that you saw maybe on your homework assignment, sometimes it switches. It might switch to where one's above and then it goes below. So when we have to find the area of this region, we're actually going to set it up using 2 integrals. This is the y equals square root of x, and y equals x minus 2. The problem is, from 0 to 2, it's bounded by the line y equals 0. You see that? We're actually going to divide it into 2 separate integrals. Notice the square root of x. When I do the integral for square root of x, it's automatically going to stop when you get to the x-axis. But then from 2 to 4, it's bounded by the curve y equals x minus 2. It's not like it took the whole curve and bounded it this way.
Wait,
Emma?
why are we dividing?
Okay, let me just make a quick sketch here. This is the square root of x, right? What's x minus 2 look like? It's going to go like that. But what's the region I'm really focusing in on? You see? We can't just take square root of x and subtract x minus 2. It doesn't work that way because the graph technically stops right here. No, still not. We have this. You have to divide it because it's bounded by this line from 0 to 2, then it's bounded by x minus 2 for this region. Want me to give a different example? You'll just do it and not need to know why? Well, thanks. Just gonna go with it. Anybody else still not see it? Or is it just look a little confusing?
It might be just you, don't worry about it.
Like I'm trying to figure out how else to express it. I mean, I could go back to another picture, but I don't know if that will make any more sense. Because, like, here's y equals square root of x. So if I did from 0 to 4, this would be my region, correct? Like if I said what's the area under the curve, it would be from 0 to 4 square root of x dx. I'm just, because my graph I'm looking at goes from 0 to 4. I wouldn't do anything from negative infinity because square root of x is only defined for greater than or equal to 0. So imagine that I took this, but I bounded it by x minus 2, which is what I have here. Notice that square root of x is not defined for values below. So I just want to have from 0 to 2 is going to be here, and then the rest of it's bounded by that line. Okay, I'm going to just keep going. Is that okay? Yeah. All right. So it goes from 0 to 2 of square root of x dx, and then I want to go from 2 to 4 of square root of x minus x minus 2, so it becomes x plus 2.
How would we know to split it up like that? Because of it going in the line x-axis?
Because of the x-axis.
Okay. We would assume that there's a y equals 0.
Here, basically think, in terms of area between two curves, you always need to have like a top and a bottom.
Oh, so there's no bottom to 0.
There's no bottom. The bottom is y equals 0. If you want to put in, if it makes more sense for you to put square root of x minus 0, you can do that. But that's really just the same as the area under the curve bounded by the x-axis. Are we all right so far? Oh, Adam? From 0 to 4 of square root of x, and then subtract 2. I don't think that would work. Because you also have this minus. I don't know, we can try it. I don't know. I don't think so, but we could try it. Go ahead and evaluate this. You could plug this into your calculator. I know you guys can do it. 3 1/3?
Well, 3.33335.
3 1/3? For both parts, for everything?
Yeah.
Did you try the other way, Adam? It worked. Okay, any questions on that one? I'll look at it. I'm interested to see that one, but let me get through this stuff first and then I'll look. Okay, so integrating with respect to y. Oops, didn't mean to cross that out. Okay, so integrating with respect to y. So essentially it's the same thing. We're just, in this case though, we're going to take the right curve minus the left curve. And our limits of integration are now the y coordinates of our bound, not the x coordinates. So basically it's like when you're working with x, everything has to be in terms of x. When you're working with y, everything has to be in terms of y. And you'll see the same will be true when we do volume. Okay, so we would do this curve minus this curve, right? Minus y. Yeah. Okay, so we actually just did this example. The exact same one, but we're going to solve it an easier way. At least I think it's easier. We're going to solve it in terms of y. Okay, so take the y equals square root of x and solve for x. What would x be? X would be y squared. And this one was y equals x minus 2. So that would imply x is equal to y plus 2. Now, if I look at my bounds, so basically I'm going from 0 to this point, they intersect at 2, 4. So I'm going from 0, or, I'm sorry, I had that backwards, 4, 2. So our bounds are going to go from 0 to 2. Which one would we put first? If it goes left minus the right? Or right minus left. So we're going to do y plus 2 minus the y squared. So our area this time looks like what? I know. It's right minus the left.
What is the right?
Yeah, but we want to write y plus 2.
I told you
It better be the same answer. Oh, don't forget, put dy, not dx.
Oh, wow.
Okay. So, the reason this way is easier is we don't have to break it up into two separate integrals. We can just write it in terms of y, and then we have just one integral to evaluate. And now, when you plug this into your calculator, it doesn't matter that everything has a y in it. If you use your calculator and you do math 9, Obviously, when you press your variable button, x's are gonna pop up, so you'll put in. Actually, it's fine. If you really want, you can use y values. You just use alpha and then use the y
It
values.
doesn't work,
Use
you only
y.
need to use
Then
dy.
but then you have to type in dy.
So it doesn't, you can only look for the variable. I don't just try not to y.
What's fine?
Yours work fine? It should work.
Oh, I don't know if it's next up to the lowercase or the.
Oh.
That could be.
But,
Okay.
but it's saying for the lowercase, I don't know if that's. It has a lowercase letter.
You understand it now? Okay. Yay, last one. And then we can go over some homework from first test. Okay, find the area enclosed by the graph of x cubed.
Yeah. If you do like that.
Okay, so we want to find the area enclosed by x cubed and x equals y squared minus 2.
Yeah.
What would you like?
So,
What would you like?
yeah, the right one, this is y equals x cubed, and this one is x equals y squared minus 2. Now, this one is definitely easier to set up if you do right minus left, right? So take, this one's already solved for x equals y squared minus 2. Go ahead and take y equals x to the third, so it's going to be cube root of 3, or y to the 1/3. Now we have to figure out the bounds. Yeah, so basically where they intersect. Yeah.
How would you do it manually?
Because you have x equals y squared minus 2. I'll show you how to. And x equals y to the 1/3. So you would set y squared minus 2 equal to y to the 1/3. Still, you're going to have to use a calculator to figure out their intersection points. On your calculator, let's say we want to do this in our graphing part. How would we graph this? Yeah, we already saw, so y equals x to the third is fine. Right. What I'm trying to explain is you could just put everything in terms of x, like solve for x and plug them in that way, or you can graph them this way, which is x to the third. How would you plug in the next part? It would be square root of x plus 2. Exactly. So you have to do the positive and negative.
So how do you find the intersection if you have to curve?
That's where the.
That's where you know how it says first curve and then second curve? If you use your arrows, you can choose a different curve to work with. What's wrong? So when I'm typing into y equals, this curve would end up being plus or minus the square root of x plus 2. Oh, if you do it the other way, it's fine. It's just your curve is going to be oriented a different way. Do you see what I'm saying? Yeah. And then you just have to flip the x and the y coordinate when you're looking at their intersection. Okay, if I graph it this way, we're fine. We're still just looking at the y coordinate. If we flipped it and we graphed it in terms of y, then you would look at the x. It's like it would flip-flop. So when I do second calculate, I want to find the intersection. So it's going to ask me for my first curve, which is x to the third. Notice when it does my second curve, it's going to jump to the positive square root of x plus 2, which is fine. And we get what for the intersection? 1.215 and 1.793. So we want the 1.793 because it's the y coordinate. Okay. I'll write it out as coordinates and then you can see. So this is going to be 1.215, comma, 1.793. We want that one. So we want to find the other intercept, or the intersection point, that is. Okay, so I want to use, it's going to say first curve. So now I'm looking at where my first curve, x to the third, intersects the negative curve.
Why does it take so long to calculate the after the
I don't know. Okay, so when I don't want to use the red one, I want to get the other line. So if I use my down arrow, it will choose this as my second curve, and then it will find the correct intersection point, which is -1, -1, which you probably saw from your curve anyway. So what does the area look like, or the setup for the integral? It's going to be from -1 to 1.793, and then it's going to be what? Y to the 1/3 minus y squared minus -2, so that'll be +2 dy. Remember when you were asking me why we needed the dx or the dy, like why that had to be? This is an example where if you're only working with y, then it has to be dy. You have to integrate with respect to y for this.
But I thought you said this was the y. The y was going to the y.
No, that was the x coordinate. It's y coordinate to y coordinate. I mean, if you want me to show you the other way? What's that?
My life was like